So now we move forward in this session, and now we would request the principal investigators and coordinators of various CRTDHs for presenting, make a presentation of their CRTDH, I'm sure would be very, very interesting. So I would first invite Dr. Chinmay Ghoroi, who is the principal investigator and coordinator for the CRTDH at IIT Gandhinagar.
Yeah, good afternoon, everybody. I'll just quickly go over our CRTDH at IIT Gandhinagar. So we are doing this thing. We are developing. We are already developed one lab and one pilot plant facilities for industries and startup, and also a few customized solution for various industries, mainly MSME sector, and also we are supporting few startup who are working in the lab. Also, we are helping in multiple direction like process development. Yeah. Yeah, process development, process improvement, process scale up, effluent treatment, and waste reduction area. Also, we are continuously arranging some of these knowledge sharing sessions, including the product testing and raw material testing. This is the lab. Whoever is interested, kindly visit us. And also, we have a site where you can see the go to the site and get the number of facilities available, and you can book the sample slot also. This is the pilot plant facility we have here. A lot of instruments are there. I think this is extraction column, this is reactor, glass reactors, and we have other thing. I think, yeah, some bioreactor. All these facilities are there here in the campus. Here I am showing one picture where MSME member from Gujarat, I think they are trying to have a 6 kg batch run in the CRTDH pilot plant. We conducted a lot of workshops and training intermittently. Even we are going to the different clusters. We call it cluster meeting, and also presented our CRTDH multiple meeting. In fact, this is the picture of the last conclave where madam has attended our stall, and then till now we reached out to more than 250 industries and interacted with multiple startups also. And also our lab is NABL accredited lab for the water treatment, water parameter estimation. Around 12 or 13 workshops we have conducted before this, and we worked on multiple technology. There is a list. I'll just go over few of these. So here Dr. Vasa was mentioning that reuse of water or reduction in the water consumption and then treatment problem. So here I am showing that this is a dye manufacturing unit where raw material is coming and product is coming out of it. At the same time, we are generating a lot of effluent of having high COD and of course the TDS also. So we came up with a catalyst where it will break this thing effluent dye content in the effluent and reduce the COD below 250 ppm or milligram per liter. In most of the cases in the textile we got success more than 90% of the reduction, and then objective is to have the recover the catalyst here, and then if the TDS is high, so then deploy the different membrane technology. In our pilot plant we have 3-4 membrane setup is there, and then recycle some amount of water so that we can treat the water as well as we can reuse some amount of water. I think that's what Dr. Vasa was mentioning. So this is so overall this process is a two-stage method. In the first stage, mainly physico-chemical method, existing method where we are coagulating and flocculating and then precipitating. And the second stage is the advanced oxidation process where we are using that newly developed catalyst for which we have filed the patent, Indian patent, and these are few data from the textile industries where we are able to meet the CPCB norm below 250. And in terms of the cost, it is coming around 120 rupees per meter cube, or in terms of the COD in kg per kg of the COD, it is taking around 28 to 30 rupees. So this calculation based on the 100 liter treatment. So, this is a small video on that. 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 So, this is a sm But I think with the scale up this data, we will be able to reduce a bit and maybe consistent. So the first stage is your coagulation and flocculation. So usual coagulating agent and coagulating agent we are providing, and then filtering out the sludge whatever we are getting. So this we have done in our pilot plant itself. So this is the first stage, end of the first stage. After the filtration, this will go to the advanced oxidation process where we will use the hydrogen peroxide and the developed catalyst. You will see that very minimal amount of catalyst is required. Only was employee here in the CRTDH here is the person who did this experiment. So this is the amount of catalyst we need to create approximately 100 liter of effluent having more than 2500 of CO2. And then in the second stage, at the end of the second stage again the filter, and the water you will see that very much clear. So this water we can recycle to the process depending upon the process water quality requirement. So this is the water it is coming up. So and then this also we have tested in 1000 liter in industry site itself, textile industry site, where we got around 90% reduction in COD. This is another video which is there in the exhibition, maybe you can go through that. This is another example how we helped MSME member. This member is already here, he is going to present. So here member has having 30, filed the patent in 30 country, but problem was that to generate the data for different kind of water. So we started with almost 100 ml, and then we went up to the 20 mld for the demonstration of their product, including intermittent like 1000 liter in the campus. This product, the aluminum hydroxide chloride, have a catalyst to reduce more than 95% of TSS. At the same time, it increased the dissolved oxygen also. So this is the photo from the run in the big plant. So I think he is going to speak about it. And then another case study like member from Bhapi. So they are producing two gas mixture, acid gas mixture, and then putting money for your scrubbing. They came to us to get some product out of that. So that's what we worked on. So we separated the gas, and then from the gas we actually did the process design for having two different products. After that they designed the plant, and now the plant is under process of installation. So maybe within 1 year or so that plant will be there. So there are 2-3 work here for during the COVID time. So we worked with the industry member to develop a oxygen concentrator. In the market there is 10 liter. So here we have used 20 liter, 12 LPM, 12 LPM, thinking that if in a home 2 persons are affected and they need normally 5 LPM. So on that sense we made that, in the market we will have that 10 LPM. We have made it 10. So in case one of the patient need more, so can be drawn from there. So that's what the objective, and product has been developed beyond the prototype. Problem is that we actually lost in terms of the price battle. So that's why product could not be launched. There is a huge difference between our product and then the Chinese product in the market. And this is the COVID second wave, almost tail part. So by that time we have almost accommodated thousands of lakhs of Chinese material here. So that's the main reason we could not penetrate the market. But in the product, these are all product grade oxygen concentrator. So the satisfaction is that now we know the technology, we know how to do that. And this one MSME from Hyderabad actually contacted. So they support the water treatment from the hospitals during COVID. They are doing that thing, and then they were asking whether we can use some new technology to reduce reduction of the COD and other thing. So we deployed the microbubble technology, where we are able to, in the 500 ml, we are able to at least reduce around 60%. And Dr. Bhasha was mentioning that import substitute. This is also during the COVID, while I was taking one course on simulation, process analysis and simulation. I have asked the student to find out, to pick up, each group has to pick up import software component and then do Aspen design. That is what it came out. So, the students were very much enthusiastic. They actually published one paper. And then I started getting response from different parts of India and then including outside. Can you please give this process? So, first time I realized that okay, it has a lot of value beyond the normal writing, there is a import substitute. So, we started working, one of the PhD student took this project and we are able to do the perhaps that para-aminophenol, para-aminophenol, yes, which is the intermediate for the acetaminophen. Mainly we are taking importing from the China. So, we are able to produce around 50-60 grams in the lab itself, in the pilot plant. Yield is comparatively less, but our process is that we came up with a catalyst and the process is only single step. So, this has to be scale up. At the same time, member also wanted one of the dye material like acid yellow 23. They are producing I think around 6 hours or so for a batch process. If you want to do it in a continuous process. So, member came in the he used to come in the CRTDH lab, worked with the BTech student itself, and we have improved a lot. In fact, we got 6 minutes time for production of their product, and this is the comparison of the product, and then the product come out from there. This is the photo with the industry members and these things. At the same time, I think this work is from the NAPL, one of the industry cooperative who is also supported this program. So, they wanted to have this cavitation. Dr. Pandit is a master of this technology. So, we tried to do something from the literature and then contacted Babu Bhai in Nandesari. So, we visited and picked that up, and then we did some small setup here, so that industry people can do their chlorination and hydrodynamic cavitation together. So, we did some generated some result for NEPL, and now NEPL actually set up their plant having that hydrodynamic cavitation and the chlorination together. Here another project where we tried to recycle the lithium ion battery. We got some interesting result, very good result, only thing that process is not that much sustainable. So, all are acidic nature. So, we are trying to come up with a green process, we have to work on that, and then we have few results on the new materials. I will not go with that, just this we came up with a new nanomaterial which will do the slow release or sustained release. Mainly for the cancer drug, will normally lot of side effects are there. So, this material what it is doing that in your blood pH the release will be much less, but once it see the cancer cell pH your delivery will be comparatively more. We have filed this as an Indian patent. Also that material we have used for the wound healing for the normal time whenever we get a cut or something. So, we normally use the your tape, no, this kind of your membrane. This is also have requirement from the army. So, that is how we started working on. We have a good result on the tensile strength, which is one of the major problem, and we also our material also give the sustained release, means once you put that band, so it will go for long time and heal the wound. I think these are also actually enhancing the cell growth on the that wound area. So, that is the picture. This is some other results to increase the again COVID, to wanted to have the more drug delivery in the lungs. So, we did some particle engineering to deliver more amount of drug. So, I will stop here because some of those things are there in the exhibition, you can look at it. Also, we are serving a lot of members through some other initiative, Kotak IIT Save Energy Mission, where we are reaching out to MSMEs and doing their energy analysis. This is the statistics we have done I think 6 months before, where lot of members who are member of the CRTDH are getting that facility, and they are successfully we are able to, our team Professor Naran Penduria's team is able to give lot of benefit and save lot of energy and reduce the carbon emission. So, key achievements of our CRTDH is that we have reached out more than 250 MSMEs industries, developed the lab and pilot plant, provided training and continuously providing, developed some technology and also working with new materials for solving some of the problems. And these are the member of the CRTDH. Thank you. So please do visit us in our your site. Thank you very much.